There are two groups of waves. Body waves, which travel through the interior of the Earth, and surface waves, which move relatively slowly and only travel along the Earth's surface. There are two kinds of body waves: P waves, or primary waves, followed by S waves, or secondary waves, which travel more slowly.
This seismometer is made to record strong ground shaking near to a large earthquake. The box has three sensors in it: one that measures the vertical component of ground motion, up-down, one that measures north-south, and a third that measures the east-west component of ground motion. When a P wave arrives, the motion will be mostly up-down, and a little bit later you'll have the S wave, or secondary wave, where the motion will be mostly sideways. And then a little later after that, you will have a surface wave where the motion is more like a rolling motion on a water wave, like this.
Okay, so what we have here are recordings from an earthquake that happened in Taiwan recently, and that was picked up by our instruments here in California. So the waves traveled all the way through the Earth from Taiwan to California, a very large distance. The first one corresponds to the P wave, the primary wave that travels the fastest right through the inside of the Earth. The second arrival, a few minutes later, is the S wave, which travels a little slower, also through the interior of the Earth. Further along, later arrivals are arrivals of surface waves that travel along the surface of the Earth and take longer to arrive.
The time it takes for these waves to arrive at a particular seismic station tells us where the earthquake happened and when. P waves are compression or longitudinal waves, like sound waves. As the wave travels through the rocks are pushed and pulled, much like the wave traveling through this slinky. The S waves are shear or transverse waves. They cause the rock particles in the Earth to shake from side to side or up and down.